Okay, I'm going to attempt to audio record my voice while the yard is being mowed and the dogs are going to be going crazy. So let's see how this works. So when we're finding the integral of an equation, I have graphed this equation y equals x squared below on the blue on the graph, and that is just a basic parabola, y equals x squared, but they want to find the area under the curve. So they want to find this area right in here and in here. Well, but as you can see, there's a curve involved in the shape, and it's hard to find the area. Now, if we were finding the area of the triangle from here to here, this one, we could do that, but the area of the red section doesn't include this little hole that's above the curve. So we have to figure out how to find the area. And some guys figured this out. I don't know who did this, but it's pretty incredible to me. So what we're going to do to find the area of that little space is find the antiderivative of x squared, which is 1/3 x cubed. And then we're going to do this. We're going to take the top number and plug it in. So it's 1/3 x, hold on, we're going to put in a 2 cubed minus 1/3 negative 2 cubed. Okay, so that's going to be 1/3 of 8, so 8/3, and then that's going to be minus negative 8/3, which is going to be 16/3. So it's going to be a little bit over 5 square units is going to be the answer. If we found the area of the two triangles, it would be 2 times 4 divided by 2, which would be 4 over here and 4 over there, which would be 8 units. The two triangles would add up to 8. 1/2 base times height. So this is 5.3 repeating. So those little curves that are in between the green lines and the blue lines, oh, I didn't change it to green. The green lines and the blue lines would add up to like 2.66 square units. Okay, so let me show you one that I can actually prove to you that I'm right. So that for those of you who go, wow, that's weird. The integral, this would be the integral between 2 and negative 3 of x plus 3. So the antiderivative, and that would be a dx, that's just the notation that they use. The antiderivative of x plus 3 is 1/2 x squared plus 3x. So if we put in the 2, we have 1/2 2 squared plus 3 times 2 minus, and here put a parenthesis so that you remember to put that minus to everybody, 1/2 negative 3 squared plus 3 times negative 3. So let's see what that works out to. That's 1/2 times 4, this, and that is a 2 plus 6, that's an 8, minus 1/2 times 9 is 4.5. 4.5 minus 9, which is 8 minus negative 4.5, which would be 12.5. So let's see what happens. When I draw that triangle here, 1, 2, 3, 4, 5, that would be a 5. And when I go here, this would be a 5. So the area of the triangle would be 1/2 base times height, which is 1/2 of 25, which lo and behold is 12.5. So as you can see, the integral finds the area under the curve. I'll see you in a little bit on Zoom, and today the homework is a picture of a page out of the book because my program no longer gives me any problems like this. So we're on our own now. Talk to you later. Bye.